Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model with the help of yolov8, and then our model will detect a person head, and we have our tracker, and then with the help of tracker we are going to assign a unique ID for each person head, and then we are going to create a counter. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to create our own custom object detection model for yolov8, which basically detect a person head, and then we have our tracker, and then with the help of detection and tracking we are going to create a counter. So simply let's get started. So first open Thony Python IDE, and we are going to install our basic packages. So go to the tools, manage packages, and search for opencv -python. Hit enter, first package, click on install button, and it will install opencv on our Windows machine. Then we need ultralytics package, so search for ultralytics, hit enter, first package ultralytics, click on install button, that's it, it will install ultralytics on our Windows machine. Then we need cvzone package, search for cvzone, hit enter, first package, click on install button, that's it, it will install cvzone. So this is how we want to install packages like opencv -python, then ultralytics for yolov8, and then cvzone. Done. We have done with our package installation steps. Now simply we need our repository. So our repository name is yolov8 head count. I will mention the link, copy paste the link inside the browser. Then go to the code, click on download zip, and it will download our zip format repository. As you can see, now it's downloading. So friends, we have done with downloading our repository. Simply open file manager, go to the downloads folder, and this is what our repository. Right click and then go to the WinRAR and extract as a folder name of our repository, and this is what our folder name. Open it, again same folder, and then we have our all the files. So first let me run the video file, then you will get the idea. So friends, as you can see, this is what our video file, where we have basically up and down frequency persons. Simple. So watch, as you can see, this person is basically going up, and then there are some person who is basically going downside, going upside, going downside. So this is what our video file, as you can see again. So as I mentioned, if you watch the video, so in this particular scenario we are not able to see a person face, or we are not able to see a person full body. So our pre-trained object detection model will basically not detect here a person. So for that we want to create, or for that we need to create our own custom object detection model which detect a person head, because we clearly see here only the person head part. Simple. So head part. So our goal is to detect, here it is, as you can see, our goal is to detect a person head, and then we have our tracker for this. As you can see, for this person also we can see head, then we have another two person, so we can only see their head. So our goal is to create own custom object detection model which detect a person head. So we have object detection, then we have our tracker. So of course we have object detection. So when we done with object detection, we have rectangle coordinates. So we are going to simply send our rectangle coordinates to our tracker. Then with the help of rectangle coordinates, our tracker will again track that object, and it will assign a unique ID for each person head. So after that, because we have now unique ID, so simply we are going to draw here two line. With the help of cv2.line function, we are going to draw here two line, and then we are going to simply say that if the person had center point, if because we have two lines, so we are going to simply say if the person had center point, if it is touch the first line, then we are going to save their ID and their current position inside the dictionary, and then we are going to call that dictionary ID, and then we can simply say if the same ID which we already have inside our dictionary, if the same ID touch our next line, then we can say that the same person is basically crossing our second line, and with the help of this idea we can simply create a counter for going upside, also for going downside. So this is what the whole concept for these projects. So first we want our own custom object detection model which detect a person head. So for that we are going to create our own custom data set. So we need images. So for that we are going to use our video file. So we have here img.py code, and inside that I have mentioned head count.avi. This is what our video file, as you can see, this is what our video file, and with the help of this code we are going to capture images, because video file is basically number of frames. Video file is basically number of images which basically continuously play one by one in while loop. So we are going to use our video file for capturing the images. So we mention here maximum frames 120, 120 is enough for this scenario. Simple. So 120 images which we are going to capture from this video file, and we are going to save all these images inside images folder. So we want to create here a images folder inside our repository. So this is what our repository. So let's just create here a new folder. So right click, new folder, and mention the name images. Just hit enter, done. We create our new folder. So right click to the images folder and then copy as a path, because we want to mention our path inside the code. So here it is, as you can see, we have here cv2.imwrite function which basically save all the images from the video file, and it will save the images inside the folder. So we want to mention our folder path. So from images, this is what our folder name. From images, let's just remove all the things. Remove it. That's it. Just remove it, and then press Ctrl+V. It will copy paste our new folder path. So here it is, as you can see, because here it is, we have double quote. So this double quote we want to remove. So remove this one, and then where we start, here it is, as you can see, two double quotes. So one, remove it. That's it. As you can see, the color is changed. It means we have successfully mentioned double quote at here and at here, only one. That's it. And then we want to mention our image name. So we are going to capture head. So I have mentioned head as an image name. So it will capture 120 images, and the name of images is basically head.jpg inside our repository and images folder. Simple. So let's just save and let's just start the code. So as you can see, our video is started and it's capturing all the images. So we have done, we capture 120 images. So if you open your repository, this is what our images folder which we just create for saving the images. Just open it, and as you can see here, we have all the images. We have 119 images. So we capture our data set with the help of video file. Now we have done with images. Now we need our label img software. So for label img software, we need Python 3.8. So if you go here in run section, configure interpreter, and here just click here, and then you will see I have already installed Python 3.8, because label img is only work with Python 3.8 for Windows machine. So here I have already installed Python 3.8. So how to install Python 3.8? Simply we want to open here Microsoft Store. So just open Microsoft Store and search for Python 3.8. Here Python 3.8 Python, just a minute, or let's just go for Python, and then it will show all the versions. As you can see, Python 3.8 which I have just installed. So just search for Python and install Python 3.8. Just click on install button, that's it, it will install Python 3.8. Now this is how you need to install Python 3.8 for label.img software. So we have done with Python 3.8 installation. So as I mentioned, just go to the run config interpreter and come over here and just select it, Python 3.8 exe, this one. C users from, this is the path where we have our Python setup file, Python 3.8 exe. Just select it, click on OK, and then inside shell, as you can see, now we have activate Python 3.8 version. Done. Now simply we want to install our label.img software. So go to the tools, open system shell, oh sorry, not open system shell, we want to open our manage packages. So just open manage packages and search for label.img. Label.img, just hit enter. First package, click on install button, done. It will install label.img. That's it. Now we are ready. We have done with label.img because I have already installed label.img. Now simply again open tools and this time open system shell and run the command label.img. Label.img, like this way, label.img, and then just hit enter. It will open our label.img software. Now we want to select our images. So open dir, go to the downloads, our repository, again same folder and images folder, select the folder. As you can see, we have our all images. So again, because I have already trained all those images, that's why the rectangle is already there. So what I will do here, I will just go here file and I will click on reset all. It will reset all label.img again, and now simply label.img, hit enter, click on open dir, go to the downloads, our repository, and then images folder and select folder. Now as you can see, completely refresh. It's delete all my work, all my old work, and this is completely reset. So I have reset label.img, so now there is no rectangle. So we select open dir, we select images folder. Now change save dir, go to the downloads, same repository, again same repository, and then our images folder, select folder. Now it will save all the rectangle text file inside our images folder. So here we want to select Pascal VOC, as you can see Pascal VOC. So we are going to simply select yolov8. So just click on YOLO. So we select YOLO and then create rectangle box and draw the rectangle box on each person head. But because our goal is to create custom model which detect person head, so we want to draw a rectangle like this way. Draw it and mention the class name head. As you can see, click on OK, save it. So we draw our first rectangle on the person head. So if you open our repository and inside images folder, as you can see, we have here head 0.txt file. This is what the rectangle coordinates. Simple. So we are successfully saving each person head coordinates. Now go for next image, create rectangle box, draw a rectangle box, same label, click on OK, save it, go for next image, create rectangle box, draw a rectangle box, click on OK and save image. So this is how we want to draw a rectangle box on our person head. But here, if you skip images, so now as you can see, if I go previous image, here it is, as you can see, we can simply draw, because we clearly see in this frame we have person head. If you go next image, here also we can see the person head is still in frame, but if you go for next image, as you can see, now there is no person head. So simply we want to skip those images when the person head is not in the frame. So simply we are going to skip all those images. So I am going to simply skip this frame. So skip next image, next image, next image, next image, next image. As you can see, next image, just skip it. there is no need to draw a rectangle, because in this frame, as you can see, there is no person head. So just keep those images, and then now from this image again create rectangle box, draw a rectangle box, click on OK and save the image. Simple. So this is how we want to skip the images if the person head is not in the frame, because we have here inside our repository, we have here delete code also. As you can see, img delete yolo.py. So this code will basically delete all those skip images. When we complete our training with the help of label img, we are going to run img delete yolo.py code, and it will delete all those images which we skip. Means we skip all those images, means there is no text file for all those images which we skip. Simple. So simply let me draw a rectangle on all images, and then we are going to start video again. So let me draw a rectangle on each person head. So friends, as you can see, I have completed a label img process, and this is what my last image 120. So let me show you here. As I mentioned, I have skipped here some frames. As you can see, in this frame there is no person head, so I have skipped all those frames. From again, as you can see, now I have drawn a rectangle over here. So here it is. As you can see, we cannot see a person head, so I have skipped 84, then 83, then from 82 again I have drawn a rectangle on person head, because in this frame we have this person head, so we can simply draw a rectangle. So as I mentioned, if there is no person head in the frame, simply skip the frame, because we have img delete yolo.py code for deleting all those images which we skip. So we have done with label img software. Just close it. Now close the shell, and again, because we are now in 3.8 version, Python 3.8, so we want to go with our default version. So again, go to the run config interpreter, go here and select the first one, which is by default Python version. Click on OK, and as you can see, we done with our default version, which is Python 3.10 version. Simple. So now we have done with img.py. So we want to open our img delete yolo.py code. So file, open, download our repository, same repository folder again, and img delete yolo.py, and it will delete all the images from images folder. As you can see, I have already mentioned the folder, because we create images folder. If you create another name folder, simply mention that name over here, and it will delete all those skip images from that particular folder which you mention over here. Simple. So let's just run the code, and as you can see, it deleted all those images which we skip, because for those images there is no txt file, and txt file is basically our rectangle coordinates which we draw with the help of our label img software. Done. So far so good. Now simply we want to create our freedom tech folder. So just open our download folder again and our repository, and here in same repository we are going to create our freedom tech folder. So right click, new folder, freedom tech, open freedom tech folder. Again we are going to create here two new folder, which is images and labels. So new folder, images, and another one, labels. So now go inside images folder, and again here we are going to create two new folder, which is training and validation. So training and validation. So again go back. So we create images folder, inside that we create two new folder. So same way we want to create two new folder inside labels. So labels, right click, new, training and validation. validation. Now simply go back, and from images we have all the data. So just press Ctrl+A and then right click and copy all the data and just paste inside Freedom Tech, images, validation, just paste it. Go back, same way in training folder, just paste it. Done. Go back and same way in labels, validation, paste it, and labels, training, paste it. Done. So this is how we need to copy paste the data from our images folder, copy paste the data, just Ctrl+A and copy all the data and just paste it inside Freedom Tech folder, labels folder, training validation, inside Freedom Tech folder, images folder, training validation, which we paste it, copy paste. Simple. So we have done. So now simply we are going to create Freedom Tech as a zip file, because we want to move our file on our Google Drive. So right click to the Freedom Tech, WinRAR, and add to archive, zip, click on OK, and it will create our freedomtech.zip file, as you can see. So now simply open your Google Drive. So I have opened my Google Drive. Go to the new file, upload, downloads, our repository, same folder again, and freedomtech.zip. Click on open. It will upload our freedomtech.zip on Google Drive. Now simply open Google Colab, go to the upload, click on browse, and go to the downloads, our repository, and inside that I have mentioned the training file, Google Colab. Select it, click on open. Now it will upload our Colab file on Google Colab. So friends, as you can see, we have successfully uploaded our Colab file. Simply go to the runtime, then change runtime type, select Python 3, select T for GPU, click on save, and then click on connect. So friends, we have successfully connected our Colab file. Now simply we are going to run our cell one by one. So let's just run first cell, click on it, play button, done. Then next cell, just click on play button and it will install Ultralytics. So friends, we have done with second cell. Now next cell, just scroll down, click on play button, it will run our next cell where we import our packages which we just install, Ultralytics. Then now we are going to cross check if Ultralytics is perfectly installed. So we are going to use here images. The image name is basically doc.jpg, as you can see, doc.jpeg from RoboFlow. So just run our next cell, just click on play button, and if we successfully install Ultralytics, so it will detect the object from this image doc.jpeg. So we have done, and as you can see, we have one person, one car, one dog in this particular image, means we have successfully installed our Ultralytics package. So we have done with package installation. Also we have cross check our package. Now we want to mount our Google Drive. So let's just watch. Okay, we have done with our upload process. So now simply we are ready and we are going to mount our Google Drive on our Google Colab. So let's just run this cell, click on play button, and simply we want to permit this notebook to access a Google Drive file. So just click on connect to Google Drive. Then you need to select here the Google Drive email, Gmail ID which you use. So just select it, continue, scroll down, again click on continue, done. Now it will mount our Google Drive on Google Colab. So friends, as you can see, we have done with this process also. So now we are going to create a dataset folder, and inside that dataset folder we are going to unzip our freedomtech.zip file. Simple. So let's just run our next cell, click on play button, and it will unzip our all the images. As you can see, we have image and their text file. We have done. Now just click on this folder icon. As you can see, just click on it, and then you will see we have our dataset folder which we create with the help of mkdir command. We create datasets folder. So just click on it, and then you will see our Freedom Tech folder, and inside that we have images and labels. So here what we want to do, we need to create here data.yaml file manually. So just go to the freedom tag, click on these three dots, click on it and click on new file. It will create a file, and we want to mention the name of the file is basically data.yaml. So data.yaml, and then just hit enter. Done. It will create our data.yaml. So just double click on the file and it will open the file like this way. It's completely empty. So here we want to mention our code. So code which I have mentioned inside a repository. So just open a repository, and inside that we have data.txt file, a text format file. Just open it, and this is what the code which we want to copy and paste inside our data.yaml. So let's just copy it as it is. Just copy it, open our data.yaml, right click and paste it. Done. And here we want to mention our class name. So just remove the old class name which is surfing and mention here our new class name which is head. This is what our object head. We want to detect a person head. And number of classes, right now we want to detect only one class, so there is no need to change anything from number of classes. And see, so one is good. Now simply press Ctrl plus S. Ctrl plus S, it will save our data.yaml. Done. Now just scroll down and let's just start our training. As you can see, this is the custom training. So it will create our own custom object detection model with 100 epochs. So we are ready. Just click on the play button and it will start our process. So friends, as you can see, it started 100 epochs. So it will take some time. Meanwhile, I will pause video. So friends, we have completed our training process. As you can see, our training process is completed 100 epochs, and our model is basically saved inside runs, detect and train folder. So runs folder, just click on it over here, detect folder, and then inside train folder we have weights folder, and inside that we have our best.pt model, which is our custom model. So just click on these three dots and click on download, and it will download our best.pt model. So friends, as you can see, we successfully download our model. Now simply if you open file manager and go to the downloads folder, this is what our custom model. So we want to move our custom model inside our main folder. So right click to the base.pt, cut, go to the repository, again same folder, and just paste the base.pt inside our repository. Now here we want to create our coco.txt file. So coco1.txt text document, coco1.txt, this is what our label file, custom label file. Open it and mention the class name which is head, because we have only one class, head. So just mention head, save it, close it. Now we have done, and we are going to simply open our main.py. This is open our main.py. It will open our code with Tony Python ID. As you can see, this is what our code. So here base.pt, our model, and I have mentioned here coco1.txt, this is what our custom class file, and head count.avi, this is what our video file. And in this code I have mentioned full code basically, where we have completely counting process. So for explanation, what we are going to do, we are going to simply go as a step-by-step process. So I have comment some lines because these lines are basically a next code. So we are going to start with only detection, and then this is the section for tracking purpose, and then we have basically tracking. After that tracking we have basically counting process. So let's just start with first detection process. We are only going to detect a person head. We are going to cross check if our model is perfectly working or not. Then we are going to move on our tracking process. Then we are going to draw the line. Then we are going to detect if the person cross our line or not. So let's just start with only detection. So this is what our basic code, where we have while loop, and inside that we have yolov8 basic detection. If you don't know how to use yolov8 with opencv and Python, I have already created a playlist computer vision with Windows, watch playlist, and then you will get idea how to use yolov8 with opencv and Python on Windows machine. So this is the basic code where we have detection, then we have our rectangle coordinates, and this is the class, means it will read our class file. So we have basically here a function. So here it is, as you can see, this is the method which basically run our coco1.txt file, and then we have our class, and here C is equal to our class list, and then we are going to draw a rectangle on our object with the help of our own custom object detection model. So let's just freeze our frame. So here we want to mention 0 for freezing our frame. So here what we are going to do, we are going to skip our frame manually pressing space button from keyboard. For that I have mentioned here 0. So let's just start our code. So friends, as you can see, this is what our frame, first frame, and here we have our person head, and as you can see there is a green color rectangle on this person head. It means our model is perfectly working. So if I skip a frame one by one, as you can see there is a green color rectangle on the person head. It means our object is perfectly detecting. Our object is to detect a person head from this particular video, for this particular scenario. So now there is no object, as you can see there is no person head. So next person is there, and there is a rectangle on the person head. As you can see there is a rectangle, green color rectangle. Now we have next person, and there is a green color rectangle on this person head also. So now it means our model is perfectly working. Now simply let's just start a while loop 1, and I have started the code, and now watch. For this person there is a rectangle on the person head, then we have a next person, as you can see, then we have a next person, there is a rectangle, then we have another person, there is a rectangle on the person head. It means our model is perfectly working, our custom object detection model is perfectly working. Then now we have again next person, there is a rectangle, then we have next person, there is a rectangle. For these two person we are detecting their head. Again there is a next person, and we are successfully detecting their head. For this person also there is a rectangle, for this person also there is a rectangle. We train only 120 images, friends, remember, only 120 images. In real scenario you need a more images for perfect detection. We done with detection section. Now simply we are going to call our tracker. So inside code we have our tracker.py. This is our tracker.py. So from tracker we are going to call all the things. So if I open our tracker, so we have here tracker class, T is capital. So from this file we are going to call our tracker class. So in main.py, as you can see, from tracker we are going to import all the things, and here if you scroll down little bit, here I have mentioned tracker is equal to tracker class, our tracker class, this one, simple. So this is how we are going to call our tracker. Now as I mentioned, our tracker need object rectangle coordinates. So for that we want to create here a list. So list.append, and inside that list we want to pass our x1, our rectangle coordinates, person head rectangle coordinates x1, y1, x2 and y2. So simply mention over here list.append x1, y1, x2 and y2. That's it. Now because now we have our tracker, and our tracker will track again same object and it will assign a unique ID. So from our tracker we will get again new rectangle coordinates, also we will get ID for each person head. So for that simply we are going to create here a new variable which is bbox_idx. bbox_idx is equal to tracker, our tracker variable, this one our tracker variable, as you can see tracker variable, and our tracker variable is basically represent our tracker class from our tracker file, as simple as. So here for tracker we are going to create a new variable which is bbox_idx, and then tracker.update. Inside tracker we have update function, so tracker.update function, and inside that we want to pass our list, here it is, as you can see our list which we append with the help of our rectangle coordinates, list.append x1 y1 x2 y2, and then here I have mentioned the list, and this list we are going to send inside our tracker.update list. And as I mentioned, again our tracker will provide a new rectangle coordinates with the ID. So for that we are going to simply call a for loop. So from bbox_idx we need now ID and the rectangle coordinates in this bbox_idx.items. This is how we are going to call our bbox_idx. For ID and rect in bbox_idx.items, as I mentioned, now we will get a new rectangle coordinates. So x3 y3 x4 y4 is equal to rect. This rect is basically our 4 coordinates. Now we need a center point. So for center point, cx is basically int x3 plus x4 divided by 2, and cy is basically int y3 plus y4 divided by 2. This is how we will get our center point, cx and cy. Now simply we are going to draw a circle, means we are going to draw a center point because we have cx and cy, and this is what our new rectangle coordinates. So we are going to simply draw a rectangle, and we have ID, so we are going to assign a unique ID for each head. So cv2.circle, cv2.rectangle, and inside that I have mentioned the new rectangle coordinates, and then we are going to push ID as a text on each rectangle top left corner. Each rectangle top left corner we have unique ID. That's it. Now this old one rectangle method which we use only with the help of a detection. Now we have our tracker, so there is no need to draw a rectangle using only detection. We are going to draw a rectangle using detection also and the tracking process also. We need here only this rectangle method. So if I save the code and if I run the code, unexpected intended. Okay, let me check here because I have commented all these lines. So we want to check if this line is in correct position. So here, now it's in line, perfect line. This is the, as you can see, this mention here, unexpected indent error, unexpected indent. So it means there is, the code is in line, not in line basically. So we want to check if it is in line. So now it's in line. This one also little bit back, this one also little bit back. Save it and run it. So as you can see, this person we have, one is basically their ID, and here I have mentioned x3 and y4. That's why this circle is drawing basically on rectangle bottom left corner. So because I have mentioned the bottom left coordinate, so we need to mention here cx and cy. So I will change these coordinates, no worry about the code. So cx and cy, now we will get the center point. It will draw a center point because we have cx and cy. As you can see, there is a blue color center point. In this rectangle, there is a blue color center point which is cx and cy, and for this person we have 1 is basically the unique ID for this person. Now there is a next person. As you can see, for this person there is a rectangle, 2 is the ID for this particular person, and there is a center point. So this is how we will track the person head. We will assign the ID for each person head, unique ID, and also we have a center point. So we have done with detection. We create our own custom model, we detect the person head. Now we use our tracker, and our tracker will assign the unique ID for each person. Also we draw a center point. Now simply our next goal is to create a counter for going down frequency and coming upside frequency. Simple. For that we are going to draw a 2 line. So here it is. I have already drawn a 2 line with these coordinates. So how do we get these coordinates? Simply, if I save the code and let me freeze here our frame again, because for drawing 2 line, for drawing a line, we need xy coordinates for starting point and for ending point. This is how we will draw a line. This is the start point xy coordinate, and this is the end point xy coordinate for drawing the line. So how do we get these coordinates? Simply, for that we have mouse event function basically. Let me show you here. As you can see, cv2.event mouse move function. So this function will basically provide us a mouse coordinate. So if I run the code, so when our frame is started, so now as you can see our frame is started, and this is our 2 line, the pink color line and red color line. So if I move my cursor over here inside the shell, as you can see we have basically xy coordinate. So if I want to start like this way, this is what my start point. So just move your cursor over here, and inside shell you will get 2 and 301. So this 2 and 301 is basically your line start point coordinate, because you move your cursor over here and you will get this particular position xy point. So if you want to, as I mentioned, for drawing the line we need start point and end point. So for start point we need xy coordinates. So just move the cursor over here, and for this point we have xy coordinate inside shell. At the end we have 0 and 385. So just mention here 0 and 385. This is what your line start point. So here cv2.line method, and here just mention the point which you will get with the help of cv2.mouse event function. Simple. And same way for end, just move your cursor over here, then you will get xy coordinate, just mention at the end. This is the end point xy coordinates, and this is the start point. So this is how you will get the coordinates, and with the help of this coordinate you can easily draw a line like I have drawn. Simple. So we have here 2 lines, the pink color line and red color line. So we have now our line. Simple. Now as I mentioned, what we are going to do here, simply we are going to create here a condition. Let's just say this person is going upside, and when the person is basically going downside, because we have their center point, so we can simply say if this center point, if it is touch our red color line for going upside, person center point, person rectangle center point, first it will touch the red color line, and then same center point touch our pink color line. So when the center point touch the red line, in that time we are going to save their ID, which is the 1, and their center point current position, means we are going to save their cx and cy when the person center point touch our red color line for going upside, So the condition which we want to mention like this way here. So what we are going to do, because we have our line, so we are going to use here this y coordinates as a cy1. So you need to mention over here cy1 is equal to 180, which is our line y coordinate, line y coordinates 180, 180, 180, 180, and for second line 245, 245. So this is what our cy1 and this is what our cy2. Here it is, as you can see I have mentioned here. cy1 is 180 and cy2 is 245. You can cross check. cy1 is 180 and cy2 is 245. So cy2 for second line and cy1 for first line. So second line is basically red color line. If I open frame, so second color is basically red color line and first color means first line is basically pink color line. So this is basically 180 and this is basically 245. And when person want to go up, it will touch our second line. So first it will touch cy2 because cy2 is 245, and then the same person center point will touch 180 cy1. So simply cy1 and cy2, and then we need to mention here offset as a 8, simple offset 8. Now we are ready and we are going to create our condition. So if cy2, why cy2? As I mentioned, because first we are going to create a counter for going upside. So when the person want to going upside, first their center point will touch our second line. So for second line we mention cy2. So if the cy2, if it is less than our cy, our center point cy plus offset, and cy2 if it is greater than cy minus offset, means if the center point touch our second line, then only we are going to draw a circle, then only we are going to draw a rectangle, then only we are going to assign the ID. So this is what our first condition. After that, just a minute, after that we are going to draw a circle. So simply we want to mention all these things after our if condition match. That's it. So if I save the code, if I run the code, so now as you can see there is no rectangle on this person head, because this person head rectangle center point is not currently touching our second line. So let's just keep the frame one by one. And as you can see now it's touch our line, and in that time we have their center point, we have the rectangle, and we have unique ID. So this is how our condition will work, and same way we are going to use this condition for cy1. Same way if cy1 if it is less than cy plus offset and cy1 if it is greater than cy minus offset, then we are going to draw a rectangle and all other things. Simple. So we have done with our first condition. Now as I mentioned, for going upside, when person head center point touch our second line, which is cy2, we are going to save their ID means 1 and their current position means their cx and cy. For that we are going to create a dictionary. So for upside I have created here up dictionary, as you can see up dictionary, and inside that dictionary we are going to save their ID and their current position when person head center point touch our second line for going upside. Simple. So this is what our condition, and after that for saving person ID we want to call our dictionary, which is up dictionary, up and dictionary. So when our first condition match, so we want to mention here up and their ID, and their current position is basically cx and cy. Now because we are saving their ID and their current position, so if you print over here, if you mention over print, and if you print our dictionary, the name of dictionary is basically up. So if I save the code, if I run the code, CV2 circle, again there is line error. So here it is, as you can see the code is not in line, that's why we have here error. So just go back and check if it is in line. Now it's perfect, it's in line. Save the code, run the code. So right now there is nothing, so we have empty dictionary. As you can see, we have empty dictionary. So when person center point, when person head center point touch our line, and then we have their unique ID and their current position inside our dictionary. As you can see, now inside the dictionary we have 1 for this person and we have their center point. Let's just keep a frame for wait for a next person. So we detect only one person, so we have their unique ID and their current position. So when we have next person, again that person ID and the current position we are going to save inside our dictionary. So as you can see, we have next person. Right now there is nothing because the person head center point not crossing our second line, which is CY2, and it's cross our line, or we can say it touch our line. We have unique ID, we have rectangle, and inside dictionary we have their ID and their current position. So we are successfully saving their ID and their current position inside dictionary. Now, as I mentioned, what is our next condition? Because we know now the person is already crossed our first line, means our second line, not first line basically, our second line for going upside. So we are saving their ID and their current position inside our dictionary. So we know that this person is already touch our second line and the same person is basically touch our first line for going upside, because we are saving their ID. So we can simply say, if the same ID is touch my first line, which is pink color line CY1, and the ID is same, so we can say that the same person is crossing our first line. That's it. So for that we are going to again call here if ID, means if the ID is in our up dictionary. So if ID in is our up dictionary, and now then we are going to cross check if the same person center point touching our first line. For that same condition only we want to mention CY1, because CY1 is assigned for our pink color line, which is first line, and red color line is basically our second line. But when the person want to go upside, basically the format is like this way. For going upside, the second line will become first line and the first line will become second line, because the person want to go up, it will touch our second line first and then the same person center point will touch our first line. Simple. For that we first mention CY2, we are saving their unique ID and their current position, then we are going to call that ID, and then we can say, we can cross check if the same ID is touching our first line, which is CY1. If the same ID touch our first line, then we are going to draw a circle, rectangle, and we are going to assign the ID. Now watch the magic. If I start here a while loop, save the code and run the code. Now we started a while loop, person touch our first line, same ID is there, and then because same person is crossing our first line, which is pink color line, and it's cross check if the same ID is there, then only we have a detection, then only we have rectangle. Watch for this person, it will touch our second line. If the same ID is there, then only we have detection, then only we have detection for going upside only. We are only doing right now for going upside, not for going downside. That's why when the person going down, there is no detection, there is nothing, because we not create a condition for going downside, we create a condition for only going upside. That's it. Clear? So far so good. So now we know that the same person is crossing our both area, so we can create a counter. How? When the person cross our both area, we have their ID. So if we want to create a counter, we want to create that particular ID as a list. So we have here counter up dot append, and inside that we are going to append the ID, and here I have create counter up with list, counter up with list. So when person cross our both line, we are going to save their ID inside counter up, and this counter up, because this is the list, so length of list is basically our counter. Length of list is basically our counter. And here if I start the code, because let me show you here, because when the person wants to go up, it will touch our second line first and it will touch our first line. So meanwhile it will cross check our ID again and again. So it will basically save our same ID again and again inside the list inside our counter up list. So for that we want to create here a condition, please don't save same ID again and again inside our list, otherwise it will create a false counter. So for that we mention here this condition, if counter up dot count ID is equal to 0, means don't save same ID again and again, because when the person want to go up, meanwhile of both both lines, it will take some time to cross our both lines. So it will basically save the ID, same ID again and again, same ID again and again inside our list, counter up list. So for that we want to create here a condition. So we create here a condition, don't save same ID again and again. So now for that I have mentioned this condition, and then we are going to simply call our counter. Here it is, as you can see, counting up. This is the variable length of counter up. As I mentioned, list counter up is basically list. Inside that list we are going to saving their ID, and the length of counter up is basically our counter, and which we are going to put on our frame. 1560 is the coordinate, and I have used here cvzone put text rect method, and we are going to counting up. This is the variable we are going to put our counter. And now if I save the code, if I run the code, as you can see we have here a counter for going upside. So right now 0, so we count one person which go up, then we have a next person, so it will increase our counter one by one. 2, as you can see we count 2 person, this one is third. 3, so as you can see we successfully counting a person which basically going up, but we not count a person which basically going down. So we only count 3 person for going upside, only count 3 person. Let's just wait. So we count up 3 person, and as you can see now there is a next person which also going upside, so it will touch our line, and then we count 4 person. Done. So we have done with going upside. Now same way only we are going to cross our condition. When person want to go down, first it will touch our first line, then the same person touch our second line. So same way only reverse the condition. We are going to save their ID and their current position. When person want to go down, person will touch our first line which is the pink color line, and the same person will touch our second line which is the red color line. So when person touch our pink color line, we are going to save their ID and their current position inside our dictionary. So I have mentioned here down session also same way. As you can see, same condition, only we are going to reverse our all the condition. Here it is. First, for going down side, first person touch our first line, so we want to mention cy1. So then we are going to save their ID inside down dictionary. So I have mentioned here a down dictionary, and we are going to save their unique ID and their current position same way. And if the ID inside our down dictionary, then same person we are going to cross check with the ID if the same person ID is touching our second line cy2, and then we are going to draw our circle, and then we have counter down a condition which basically say like don't count same ID again and again. So same way Same things for going downside, and then we are going to put our counter. That's it. This is what our code. Now there is no need to check printf, and then simply start the code. Now we have a both side counter. As you can see, we have both side counter. One person count for going upside. The next person is there. Second for going upside. Three person count. Then for going downside, one person count. As you can see, we count here one person for going downside, then 2 and 3. So right now 2 and 3, as you can see, 3 person for go up and go down. Going downside, we have a next person is there, fourth one, as you can see. So we successfully create a counter. We create our own custom object detection model with the help of yolov8, which detect a person, the person head, then we track, we assign a unique ID, and then we create a counter. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.